Hello everyone. We are going to discuss about the tapered slip forming technique used in the construction of cooling towers. Cooling towers are among the tallest reinforced concrete structures built in civil engineering. Because of their great height and unique hyperbolic shape, they require a special construction method that is accurate, safe, and fast. This method is called tapered slip forming. In this lecture, we will understand what a cooling tower is, where it is used, why tapered slip forming is selected, its construction sequence, important components, advantages, limitations, and quality control measures used during construction. Let us first understand what a cooling tower is. A cooling tower is a structure used to remove unwanted heat from industrial processes. It cools hot water by transferring heat into the atmosphere, reducing the water temperature before it is reused. These towers are commonly built as tall, open-topped, hyperbolic reinforced concrete structures. Their unique shape provides strength and allows efficient airflow for cooling. Since cooling towers are very tall and carry significant loads, they require high dimensional accuracy during construction. Continuous construction methods are preferred because they improve quality, reduce construction time, and ensure better structural performance throughout the project. Now let us see where cooling towers are used. Cooling towers are important in industries where a large amount of heat is produced during operation. They cool circulating water so that it can be reused again. They are widely used in oil refineries, petrochemical plants, chemical industries, thermal power stations, nuclear power stations, steel plants, and other large industrial facilities. Cooling towers are also used in HVAC systems to cool large commercial buildings. Without cooling towers, industrial equipment may overheat, reducing efficiency and increasing maintenance costs. Therefore, cooling towers play a vital role in many engineering applications today. Cooling towers can be classified in two different ways. The first classification is based on air induction. In this category, cooling towers are divided into natural draft towers and mechanical draft towers. Natural draft towers include reinforced concrete hyperbolic towers that use natural airflow. Mechanical draft towers use fans and are divided into induced draft towers, where the fan is at the top, and forced draft towers, where the fan is at the bottom. The second classification is based on airflow direction. These include cross-flow towers with horizontal airflow and counterflow towers with vertical airflow. Now let us understand why the tapered slip forming technique is used for cooling tower construction. Cooling towers have a hyperbolic shape, which means their diameter changes continuously from the bottom to the top. The wall of the tower is also inclined at different angles as the height increases. Because of this changing geometry, ordinary vertical slip forms cannot produce the required shape accurately. Therefore, engineers use tapered slip forms. This system automatically adjusts the position of the formwork according to the changing radius of the tower, ensuring accurate dimensions, continuous construction, improved quality, and better structural performance throughout the project. The construction of a cooling tower using tapered slip forming follows a systematic sequence. First, the foundation is constructed to safely support the entire structure. Next, a starter wall is built to provide a base for installing the slip form system. After installation, reinforcement steel is fixed according to the design drawings. Concrete is then placed continuously inside the formwork. Hydraulic jacks slowly lift the formwork upward as the concrete gains sufficient strength. During lifting, taper adjustments are made to maintain the required tower profile. Finally, surface finishing is completed, and the cooling tower construction reaches completion safely and accurately. The tapered slip form system consists of several important components that work together during construction. Inner and outer form panels provide the required shape for the concrete wall. Hydraulic jacks lift the complete formwork assembly upward. Jack rods support the hydraulic jacks during movement. The working platform provides space for workers to perform construction activities safely. A hanging scaffold allows finishing work below the formwork. The reinforcement platform is used for fixing steel bars before concrete placement. Concrete placing equipment delivers fresh concrete, while surveying instruments continuously check alignment, dimensions, and the correct shape of the cooling tower. Let us understand the function of each component in simple words. The form panels hold fresh concrete until it becomes strong enough. Hydraulic jacks provide smooth and continuous upward movement of the entire system. Jack rods carry the load of the lifting arrangement. The working platform allows workers to place concrete, fix reinforcement, and inspect construction safely. The hanging scaffold helps workers finish and repair the concrete surface below the forms. Concrete placing equipment ensures a continuous supply of concrete without interruption. Surveying instruments regularly measure height, diameter, vertical alignment, and wall position to maintain the correct geometry throughout construction. Quality control is very important during tapered slip forming because the construction is continuous and the cooling tower is very tall. Engineers carry out regular survey checks to ensure the tower remains in the correct position. Verticality measurements confirm that the tower is not leaning. Diameter verification ensures that the changing shape follows the design accurately. Wall thickness is checked to maintain structural strength. Concrete samples are tested to verify the required strength. Temperature is also monitored because it affects concrete hardening. Finally, the concrete surface is inspected to ensure a smooth finish without cracks, honeycombing, or defects. The tapered slip forming technique offers many advantages in cooling tower construction. One major advantage is rapid construction because the work continues without stopping. Continuous operation reduces delays and improves overall productivity. The technique produces a high-quality concrete surface with very few construction joints. It also reduces labor requirements because many activities are carried out simultaneously on the working platform. Better dimensional accuracy is achieved through continuous surveying and automatic taper adjustment. This method is economical for constructing tall reinforced concrete structures. Finally, continuous casting improves the overall structural integrity, making the cooling tower stronger, safer, and more durable. Although tapered slip forming has many advantages, it also has some limitations. The initial investment is high because specialized equipment and hydraulic systems are required. Skilled engineers, supervisors, and trained workers are necessary to operate the system safely. A continuous supply of concrete must always be maintained because stopping the process may affect construction quality. Once slip forming begins, it is difficult to interrupt the operation. Weather conditions such as heavy rain, strong winds, or extremely high temperatures can create construction problems. In addition, accurate surveying throughout construction is essential, making the process technically demanding and carefully controlled. Let us summarize today's lecture. A cooling tower is a tall reinforced concrete structure used to remove waste heat in many industries. Because cooling towers have a continuously changing diameter and wall inclination, tapered slip forming is the most suitable construction technique. We studied the construction sequence, important components, quality control measures, advantages, and limitations of this method. The technique provides speed, accuracy, safety, and excellent structural performance when proper planning and supervision are maintained. I hope this lecture has helped you understand the basic concept of tapered slip forming and its importance in modern cooling tower construction. Thank you for your attention.